Okay, good morning. Today we're going to be learning about slopes and rates of change. We're going to learn how to find them using two ordered pairs in a formula, and we will also be talking about how to get rates of change from graphs. All right, so let's kind of dive in. Most of us know when we hear, if you hear of people skiing, right, they're hitting the slopes. Slope refers to the steepness of an incline or the steepness of a line. Now, if the absolute value of a slope is a high number, right? Like let's say we have the slope of 100, that means that line is super, super steep. If the absolute value of the number is low, let's say you have a slope of a half, then we say it's very shallow, or the line tends to be a little bit flatter. Now, in real life, the slope represents a rate of change. So a lot of times you're going to see the amount of money saved per month, right? There's two different quantities that end up getting compared in this case, right? Money and then per month. So how much money is accruing per the number of months that have gone by. That represents our rate of change. Similarly, our rates of change is a ratio. When we look at a graph, it is specifically the change in y over the change in x. Now, many of you may have heard rise over run, right? Rise is the amount of change vertically, and run is the amount of change horizontally on a graph. Vertical refers to your y, horizontal refers to your x. Now, there are four different situations that occur when you find a slope. You could get a slope that has a positive value, okay? Now, I don't know why we do this, but in math, we represent slope with the letter M. So if your slope is greater than 0 or positive, you end up with an uphill line. Now, it is uphill when you look at it going from left to right. If you have a slope that is negative, right? So M is less than 0, you end up with a downhill line. If you have a slope of 0, you end up with a horizontal line. And if you have an undefined slope, you end up with a vertical line. Now, the positive and the negative slope everyone typically gets. The 0 slope and the undefined slope are the things that tend to confuse people. If you look at your ratio, your rise over your run, in a 0 slope situation, that would give you 0 over some change in x. So notice in this situation of a 0 slope, there is no vertical change, only horizontal change, and therefore it gives you the 0 slope. In an undefined slope, if you're talking about a ratio, the only time you're going to get undefined is when the denominator is 0. So that means there's no change in x, but there is vertical change. So you can go up and down on the line, but the line never goes left or right. And again, this one, if you think of the word undefined and think about when that happens mathematically, that happens mathematically when the denominator is a 0. So that will kind of help guide you. Now, there is a formula that you can use to find the slope of a line. And we're going to actually talk about it and derive it ourselves. So what I want you to do is think about how you find the change in something, right? When you go to the store and you go to Starbucks and your drink's $4.95 and you give them a 10, how do they determine what change you're going to get back? Well, they use subtraction in order to do that, right? So when we go to find the change in y, then if we were given two ordered pairs, let's say we'll call them x1 and y1 for right now, and x2 and y2, so those are our 2 points, then the slope would equal the change in the y's. So you could take y1 minus y2, and then the denominator would be the change in the x's, which you would subtract. X1 minus x2. Now, sometimes some books will teach you that it's y2 minus y1 over x2 minus x1. It doesn't matter which formula you use. The thing that matters is that whatever point you start with in the subtraction process, you use in the denominator as well. So if you look at the first formula of y1 minus y2, that meant we started with the first point. So that means we have to start with the first point in the numerator, first point in the denominator. If you start with the second point, right, x2 and y2, then when you start your change subtractions, right, your y2 minus y1, you also have to coordinate that in the denominator using x2 minus x1. All right, today what we're going to do is we're going to actually practice finding the slope given two sets of ordered pairs. And then we're going to go into some more complex problems if you kind of peruse down below, where we give you the slope and you're missing one of the coordinates in the problem. Now, the reason we give you problems like that is that when you get to the ACT and the SAT, when you're a junior and senior in high school, and you're taking those placement tests for college, those types of questions are what they use to assess slope on those tests. They're not going to be as straightforward as finding the slope given two ordered pairs, right? But these first set of examples is sort of like a foundational setting of how to use the formula and manipulate it. All right, so our first problem, if you copy it down in your notebook, asks us to find the slope of the line that goes through the points of 1, -2, and -4, 7. So we're going to go ahead and we're going to subtract our y's, right? So it's the change in y over the change in x. Now that funny little triangle that I put, that triangle means delta. It's a Greek letter delta, and it means change in. So a lot of times mathematicians, we like to shorten things. So a lot of times we use these symbols to sort of shorten our notes so that we don't have to write change in y each time. All right. Pick a point that you want to start with. So I'm going to start with the first one, 1, -2. So if I subtract, I start with that y coordinate of -2. I'm then going to subtract the y coordinate of the second ordered pair from that. So it would be -2 minus 7. Then in the denominator, I'm going to start with that same point, only I'm subtracting the x's. So it'll be 1. And then if you notice, our next x term is -4. So it's 1 minus a -4. Now, minus a -4. Let's talk about what that means. If you have the negative next to a negative, we should know that that is the same thing as a positive. So 1 minus a -4 is the same thing as 1 plus 4. And then we just simplify. So we end up with -9 over 5. Now, what I want you to do is think about if you were to graph that, what would it look graphically? What would it look like graphically? Well, because our slope is negative, it would end up looking like this second picture back up here, right? It would be a downhill line. So the nice thing is that when we know what the slope of a line looks like, it helps us to gain a picture or a visual of what that is representing on a graph. All right, let's take a look at the second example. It says find the slope of a line through -5, 14 and -16, 10. So again, we're going to find our change in y over our change in x. I'm again going to just start with that first point of -5, 14. So the y coordinate there is 14, and we're going to subtract the y coordinate of the second ordered pair from it. So that's going to be 14 minus 10. And then when we go to subtract the x's, again, we start with that ordered pair. That x coordinate there is a -5. And we're going to subtract the other x. So minus a -16 becomes a plus 16. And then we reduce. So we get 4 over 11. Now again, challenge yourself. What would that look like graphically, right? That would end up being an uphill line because it has a positive slope. All right, number 3. We're being asked to find the slope of the line through -3, -5, and 2, -5. So again, we're looking for a change in y over a change in x. I'm going to start with the first ordered pair. The x there is -5. The y in that case is a -5. And we are going to subtract the other y from it. So -5 minus a -5 becomes +5. Now at this point, -5 plus 5 we know is 0. When you take 0 and you divide by anything, you're going to get 0. So I'm not even going to worry about the denominator because I know that in the numerator it's 0, so the whole thing is going to be 0. Now think back to the fact that this is one of our special case graphs, right? If we have a 0 slope, what would that look like graphically? And a 0 slope means we have a vertical line. All right, example number 4. We need to find the slope of the line through 2, -1, and 2, -3. So we're getting our m, or our slope. I'm going to start with the first ordered pair again. Our y coordinate is a -1. If we go to subtract the other one from the other side, it's a -3. So -1 minus a -3 becomes +3. And then in our denominator, we're going to subtract our x's, so we get 2 minus 2. So this gives us 2 over 0. Now, remember, anytime the 0 is in the denominator, it is undefined. So you either need to write out the word undefined, or you can use the null set symbol, which is a 0 and a line through it. But what this means is that there's no slope that exists. All right, number 5 is sort of like a little bit of a challenge problem. It's kind of using the formula and knowing how to manipulate it to get back to one of the missing coordinates. So in number 5, it asks us for the value of y so that the line passing through -1y and 4, 4 has a slope of -2. Now you're still going to use your formula, but you want to start off with the fact that you know that the slope is a -2. So rather than writing m equals, we know m. m is -2. So we know that -2 is equal to this quotient. Now, again, starting with the first point, if we subtract the y's, that would be y minus 4. And then in the denominator, we would have -1 minus 4. So if we simplify that, we get -2 equals y minus 4 over -5. Now, we've talked about how to solve equations like this, right, in the past. We know that we can multiply through by a common denominator to eliminate the fraction. So let's multiply through by -5. When we do that, you're going to come out with a positive 10 equals y minus 4. And then when you add 4, you get y to be 14. Now, if you really wanted to check your answer, you can in this case, right? Because if you were to plug that back in and say that you have the point -1, 14 and 4, 4, when you get the slope of that line, you should get -2. So let's kind of check it. M equals, if I subtract the y's, that's 14 minus 4, and then in the denominator, subtracting the x's, -1 minus 4. So you get 10 over -5, which is the slope of -2. So you know that you did it correctly. All right, number 6. In this case, they ask us for the value of x so that the line passing through x2 and 1/4 and -3/5 has a slope of -13/10. It's going to be done the same exact way. So our slope is negative 13 tenths. We're going to start off with subtracting our y's. So that's going to be 2 minus a negative 3/5. So it's going to be plus 3/5. And then in the denominator, we have x minus 1/4. Now, this one looks a bit scary, right? Because there's lots of fractions, and off on the right-hand side, you have what we call complex fractions. You would still do the same exact thing. So if you are multiplying through, or what you might want to do in this case too, is you could just, you could simplify it out, or if you want to, you know what, it might be easier to do that. Let's simplify it in this case. So if we add, let's keep our negative 13 tenths. And then if you take 2 plus 10, or plus 3/5, if you think of 2, 2 is the same thing as 10/5. So 10/5 and 3/5 is 13/5. And then here we have x minus 1/4. Now, if you think back to junior high, you might remember that when you have two ratios, right, two quotients equal to each other, you can set their cross products equal to each other. So that means that negative 13 times x minus 1/4 would be equivalent to 10 times 13/5. Well, if we distribute, you get negative 13x plus 13/4. And 10 times 13/5 is 26. Now at this point, you may want to clear your fraction out by multiplying through by 4. 13 times 4 is going to give you 52, so it's negative 52x plus 13, and then 26 times 4 is going to give you 104. And then if we subtract our 13, negative 52x is equivalent to 91. And when we divide by negative 52, you get negative 91/52. Now, you can always check that by plugging it back in and verifying that your slope ends up being negative 13 tenths. All right, number 7 and then 8 through 10 work with rates of change in the real world setting. So, if you take a look at number 7, it's asking us how much did John save per month. So what we're trying to figure out is the rate of change given the graph. Now, remember that slope is the change in y over the change in x. Now, looking at our graph, we can tell we have a linear situation. We have a straight line. The rate of change is the same each time. So if you investigate how much did it change vertically for each month. So if you look just between two of the little points here, we can see that between month 1 and month 2, there was an increase of $100 vertically. And if you look at the x-axis, there's a change of 1 month. So that means there is a change of $100 per month. And that is the slope or the rate of change. All right. Numbers 8 through 10 ask us to reflect on this particular graph. Now, notice that this is Karen's marathon. This is depicting her timing over the course of her 26.2 miles. So if we just kind of dissect this, our x-axis is the time, y-axis is our distance in miles. If you look at it, it took her, looks like about 6 hours to complete it, right, to complete her marathon. And then it asks us some questions. So it says, when did Karen go the fastest during her marathon, and how do you know? Well, let's take a look, right? We have these different pieces denoted here, A, B, C, D, E, F. And we're trying to figure out, when did she go the fastest? Well, if you remember when we talked about slope, we know that when it's steepest is when there's the largest incline. So if you look at your graph, there's a steeper incline at A, there's a steeper incline at D, and there's a steeper incline at F. And what we want to figure out is which one of those is the steepest. Well, graphically, right, if we look at A and get the slope, we're looking for the change in Y. So at A, she went from 0 miles to 6 miles, and her timing was for 1 hour. So the slope of A is 6. Now the other steep spot was at D. Well, if you look at D, her distance went from 9. Her distance went from 9 miles to 18 miles, right, in that little segment. So the difference between 9 and 18 is 9. And her distance in time looks from about 2.5 hours, right, if we were to extend this down, about 2.5 to 4. So divided by 1.5. Now, if you take 9 and divide it by 1.5, you end up with 6. So A and D are actually the same. Now, let's take a look at F. F was between this little segment right here. So the change in distance went from 18 to the end. Now, this is something you'd need to know. A marathon is a distance of 26.2. So if you take your 26.2 and subtract 18 from it, you get a distance of 8.2. And her timing went from probably about, what does this look like? I don't know, maybe 4.75 to 6. So if we take 6 and subtract the 4.75 to get the timing difference, that's 1.25. And then if we subtract those two, or divide those two values, we get a slope of 6.56. So when we're being asked, when did she go the fastest? If we compare these slope values, the fastest was during time F. And how do we know? That is when the slope was the largest. All right, for number 9, when did Karen go the slowest during her marathon? Now, remember, slowest is when the line is sort of like the steepest, or not the steepest, the shallowest or the flattest. Well, we've already looked at A, D, and F. So the only other segments we have are E, C, and B. Now, if we compare those, B, she went up 3 miles in 1 hour. So that was 3 miles per the hour. If you look at C, it definitely looks like there was an incline in the number of miles, right, over the time. So she did go up a little bit, and we would say that's definitely less than 3, right? And then if you examine E, it looks like her distance didn't change, but the timing changed. So at E, it was totally flat. Now, if it was totally flat, we want to think about what that means in terms of the slope there. That means that the slope was 0. So in the context of the problem, if she didn't have any change in her distance, but her time stayed moving, then that just meant that she wasn't moving. So that meant that she was just standing still. Maybe she stopped to take a water break during that time, and she wasn't running at all. So if we're being asked when she goes the slowest, we can clearly see it would be right at the C time. She's going a little bit, maybe she was just walking during that time, but that is definitely the shallowest. So there we would say slope is the smallest. And then for number 10, did Karen take any breaks during her marathon? Well, we just alluded to that, right? And she did at section E. The slope is 0 there. All right, we just finished up notes for today. Again, please log into Google Classroom. You want to do the assignment for today. Please try to have that done by 11, and then we will be back on Google Meets at 11:30 to go over everything and then preview what is coming next in the course. All right, have